Hello, and welcome to Lesson 5. Today we're going to be talking about sets, absolute value, and addition of signed numbers. So let's go ahead and get started. To begin with, we're going to talk about sets. So in mathematics, when we refer to sets, we're referring to collections of objects. Collections of objects. And those objects could be anything. We could have a collection of hats, for example. Or maybe we have a collection of marbles. Or maybe we have a collection of Legos. All of these could be considered individual sets. All right? Now, sometimes when we have a set of something, we like to have a set within a set, kind of a subset. So for example, if I have this set of Legos, maybe I want to separate the Legos out so that I have a set of red Legos that came from the set of Legos altogether. So here I have my set of red Legos coming from the set of Legos. So we kind of have a subset within a set. And that's very common in math. We have these great big sets with all kinds of things in them, and then we categorize them, so to speak. We take that and we divide it up into different subsets. Maybe it's a group of red Legos. Maybe it's a group of blue Legos. Maybe it's a group of yellow Legos, right? So we have all of these subsets within this larger set. All right? So this is very useful. And one of the reasons it's useful is that we're able to organize different concepts and different ideas. And being organized is always a good thing, right? So, for example, if I have as a set, maybe the set includes all of the clothes that I have in my closet, for example. And if it's all just thrown in there and jumbled around, it's not very useful because I'm not going to be able to find the things that I want to use when I want to use them. It becomes clumsy. It's difficult to get to things. It's difficult to know what you have and what you don't have and where things are and all of that. So what do? We take that set of clothes and we divide it up into further sets. So let's get a visual on this. So if I have something that looks like this, for example, here I have my closet or someone's closet, let's say. And in it, we have all of these sets that we've organized. Okay, so you can think of the closet, all of the clothes as being one great big set. But then within that set, we have multiple other sets. Maybe on one side of the closet, we have our, the woman's side. All right. So this is this red box here. This is a set of women's clothes that's been taken from the larger set of clothes in general. And then maybe over here, we have another set for the men's clothes in this green box. Okay. So we've divided up this collection into two different sets. All right. And then over here, we have maybe the set for shoes. Women's or men's, it looks like, maybe. Okay. So there's another set within a set. And again, this is very useful because if I want to find some, men's pants, I can go into the men's section. The men's section and find what I'm looking for. It's not all jumbled up in just this big pile of clothes. All right. Now you could even dig deeper than this and go to the women's set and divide that up into further categories. So, for example, you might have the set within the women's that is going to be the set on hats. Whoops. Let me get the right tool here. That'll be the hats. So maybe that's this section right in here. Right? Or maybe we have a section within the women's section that's dealing with purses or bags. All right. So we have all of these sets within sets within sets, and it helps us to organize our thoughts and these objects so that they become more usable. The same thing applies to math. So when we think of math, there are lots of numbers out there, and sometimes it's good to organize those numbers into sets so that they become more usable to us. So for an example, we learned in a previous lesson that there is a set of numbers called the natural numbers. the natural numbers. Do you remember what they were? Another name for this is the counting numbers. Means the same thing. And you remember that the counting numbers, or the natural numbers, were the numbers 1, 2, 3, 4, 5, so on and so forth, forever. All right? Well, this is a set. This doesn't include all of the numbers in math. It only includes some. And it would be considered a set. Now, to designate a set in mathematics, we use specific notation. So to write something as a set, we use these curly braces, all right? And we enclose the numbers within those curly braces. And that all that means is that this is a set. It's considered a set, all right? So this is the set of what we would call the counting or natural numbers. That is one set. Now, there are other numbers that we could organize into further sets, okay? The other one that we have learned would be whole numbers. And the set of whole numbers is simply everything that's in the counting and natural numbers, except we add one additional number, and that is the number 0. So 0, 1, 2, 3, 4, 5, and so on and so forth. This is the set of whole numbers. Okay, we're just adding an additional number, 0, but it is still a set. From there, we could add some more numbers to make to make yet another set. So let's think about doing that. What if we were to add some negative numbers into this? So what if we have the set, and now we say, you know what? We're going to have the number 0. We'll have the number 1, 2, 3, and so on and so forth. But then we're also going to have the number -1, -2, -3, so on and so forth. Okay? This set also has a name. This set is known as the set of integers. All right? So the difference between the set of integers and the set of whole numbers is that the integers include negative numbers as well. So I might ask you, does this set integers, does that include all the numbers that are out there? Think about that for a second. Does it include, or could we create yet another set that has even more numbers in it? Well, the answer is yes, we certainly could. Because think about this set. What isn't included in this set? Well, what about fractions, right? Parts of a number. That's not included in here. So that would be yet another set of numbers, which we're not going to get into today, but that would be a set of numbers that we call real numbers. So that includes all of our fractions and everything else. All right? But we'll get into that later. Right now, I just want you to understand what a set is, and in particular, I want you to know these 3 sets: counting and natural numbers, whole numbers, and integers. All right, let's move on. So now let's talk about another concept. We're going to talk about the concept of absolute value. All right, now absolute value is something that we'll be using fairly often, and the best way to maybe describe it is to look at our number line. All right, so here we have our number line, and again, we've talked about this in the past. We have all of our positive numbers and our negative numbers. In fact, we have all of our integers listed on this number line. And if we're referring to absolute value could be thought of as the distance a number is away from 0. It's one way to think of it. So for example, if I take the number -3, what is the absolute value of the number -3? Well, if we find -3 on our number line, it sits right here. This is where number -3 lives. How many units away from 0 is it? All right, so here's our 0. So we have 1 unit, 2 unit, 3 unit, right? It's 3 units away from 0. So the absolute value of -3 is going to be 3. That's how many units away from 0 it is. All right? And to denote this, we write the absolute value by using these vertical bars. So whenever you see these vertical bars enclosing a number, that's asking you that's telling you the absolute value of -3. All right, and what is it? It is 3. All right, so let's try another one. What about if I have the absolute value of a 4? What is the absolute value of a 4? Well, again, if we go to our number line, here's where 4 lives. How far away from 0 is it? How many units? It's 1, 2, 3, and 4, right? So it's 4 units away. So the absolute value of 4 is simply 4. Nothing really changes when we look at the numbers. We have a positive 4 in here, and the absolute value is indeed a positive 4. Up here, when we have the absolute value of a negative number, it does give you a solution or an answer that is not negative. The absolute value will always be a positive number because you can't be really negative spaces away from 0, negative units away from 0. You're always going to be a countable number of units away from 0. So we have to use counting numbers, which remember are the numbers 1, 2, 3, 4, etc. All right. So here we have the absolute value -3. It's 3 units away. The answer is 3. Okay. Now, what about something like this? What if I have the absolute value of a -2? I won't confuse you with that. I'll say the absolute value of a 3 plus 4. Sometimes you'll have this, and we'll look at this more later. We can enclose expressions inside of our absolute value bars. And when that happens, we simply simplify the expression within the absolute value bars first before we give the absolute value for it. So we'd simplify this by saying this is equal to the absolute value of 3 plus 4, which is 7. And then the absolute value of 7 is 7. All right? So that's really all that we need to know at this particular moment in regard to absolute value. One other thought I might leave you with here. Well, actually, I think I've got some on the next page here. Here we go. Let's try a little bit of practice. Why don't you go ahead and pause the video. Try to find the solutions to these on your own, and then we'll just double check them and do them together. All right, so the first one, the absolute value of a -2. Pretty straightforward, right? How far away from 0 is a -2? It's going to be 2 units away, right? So the absolute value is simply 2. All right, the absolute value of 4. I think we just did this one. What's the absolute value of 4? It's going to be 4. This one, the absolute value of a 4 minus 3. Well, first we simplify what's in the absolute value signs here. So 4 minus 3 is 1. Is 1. And the absolute value of 1 is going to be 1. So 1 is our solution. Now, how about this one? 6 minus the absolute value of 3. The first step is to solve for the absolute value. So we have 6 minus, we're not going to touch that. We're going to leave it just the way it was. And we'll solve for the absolute value of 3. The absolute value of 3 is indeed 3. And now we can go ahead and solve the problem. 6 minus 3 is 3. There's our solution. Next one, we have 3 minus the absolute value of a -2. So what's the absolute value of a -2? And again, we'll first, rewrite the first portion of this problem just the same without changing anything. The absolute value of a -2 is a 2, right? But now that becomes kind of a -2 because of this negative sign here, which we placed here, right? So now it's 3 minus 2, which is going to be 1. And there we have it. So hopefully that was pretty straightforward for you. Absolute value is not complicated, and it's pretty easy to understand. So let's move on here. We're going to talk now about the addition of signed numbers. And this is something that we really do need to go over because it really is a foundational concept that you'll be employing throughout all of algebra, really. So when we consider a certain addition or subtraction expressions, we have probably been used to doing things like this. So if I have 6 minus 4, we think of this as 6 and I take away 4. All right? That's probably the way you were taught in grade school. You have 6, you take away 4, what do you have? Well, I have 2. Now in algebra, this kind of thought process can become a little hairy because sometimes in algebra we have things that look like this, 2 minus 6. All right? And if we use our old thought process, we would say, okay, we have 2, and now we need to take away 6. And up to this point, you might have said, well, that can't be. If I only have 2, you can't take away 6 from that. I don't have 6. I only have 2. And that's where that way of processing these problems kind of falls short. All right. So we need a different way to think of these problems. And that's the algebraic way. All right. So how do we do that? Well, to begin with, in this particular textbook, they talk a lot about number lines and using the number line as a way to solve for these addition problems. All right. Now, this is not the way you'll be doing it throughout the entire book. I'm going to say that up front. But it is the way that they try to introduce this. We will find better ways to do it, but this is kind of a good first step anyway. So let's pull up our number line here again, and we'll walk you through it. So to begin with, what we'll do is treat each of these numbers as kind of its own separate identity, okay? So, and each number has 2 components. So you have the number, let's say a number that we have is maybe a 4, but also with that number, there's always going to be a sign related to it, all right? And it's either going to be a minus sign or it's going to be a plus sign, like a +4, all right? Those are really our only 2 options. We have a -4 and we have a +4, okay? Now, in algebra, we like to think of these numbers and these signs as kind of being connected to each other. So they're kind of glued together. We don't really separate them. And if you see a number that doesn't have a sign, such as maybe the number 3, if it doesn't have a sign, that's because it is implied or it is assumed that there is an invisible plus next to this 3. It's just invisible. It's there, it's just invisible. So you have to kind of keep that in your head. If you see a number all by itself, just automatically in your head, you should be thinking, oh, there's an invisible plus sign next to that to indicate that this is a +3. All right? All right. So getting back to these problems, when we solve these algebraically, the first thing we're going to do is separate all of these numbers into kind of their own little piece. Okay? And we're going to add them together. Add them together. We're always adding. All right? There are several different ways of thinking about this in algebra, but the book stresses this, so I guess this is what we'll be saying as well, that in algebra, we will always be adding. We will never be subtracting. Never be subtracting. All right? So how do we do that? Well, let's first divide this expression up to into its individual numbers. So we have a 2, but I just said if it's all by itself, it actually has this invisible plus sign next to it. So we're going to rewrite that as a +2. All right? And then what we're going to do is we're going to put this in parentheses. All right? That's kind of just one little piece of this expression, a +2. The other piece that we have is a -6, right? So we're going to write that over here, -6. And we're going to put that in parentheses. All right. Now we will always add these different pieces of the problem together. That's why I said a minute ago, we're always adding with these expressions in algebra. So we put an addition sign right here. We're adding this number with its sign, or this number and sign with this number and sign. We're adding those 2 together. But we first need to split them up so that we see that very clearly that which sign goes with which number. All right. Now, once we've gotten this far, I'm going to make a little more room here. The next step that the textbook is going to tell us to do is to use the number line. And on the number line, we always start with 0, okay? And we just draw basically a dotted line up from 0. And if a number is positive, we're always going to be moving to the right. So to the right means positive because that's where all the positive numbers live. And then to the left means negative because that's where all the negative numbers live. All right? So our first number here is a +2. Maybe I'll change colors here. We have a positive 2. So from this dotted line, we're going to move over to the positive 2. All right, so we're now above the positive 2. So in a sense, we've gone 2 units. We started at the 0, and we went over 1, and we went over twice. We went 2 units over. All right, to the right, because this is positive. Now from here, we'll draw a dotted line straight up. And our next move is this one here. And we're going to move to the left 6 units. So now we move 1 unit, 2 unit, 3 unit, 4 unit, 5 unit. 6 units would put us right about here. So we're going to move over this direction 6 units. So we went positive 2 units this way. We went negative 6 units this way. And then we look and see, where does that put us? And that puts us right here at the negative 4. So the solution to this problem is a negative 4. All right. Now, hopefully this doesn't seem like I'm really trying to make this complicated. Believe me, this will get easier, and we will not always be using this number line. All right. It's just a way that they're using to kind of illustrate what's going on. What we're really doing is we're taking a positive 2, we're adding that with a negative 6. We're summing the two together, a positive 2 plus a negative 6. And then in our heads, we have to think about, okay, we're at the positive 2, and then we're adding a negative 6, which means we go 6 units to the right, or left, excuse me, and that puts us right at the negative 4. So it's all about moving from left to right and right to left, depending upon the signs. All right? All right. So hopefully if that was really confusing, it'll come once we get a little more practice here. So let's try a couple. So go ahead and maybe on a separate sheet of paper, you can even draw a number line out, and and then you can try practicing this on your own. So take the first one, try it, see how you do. And if you're really lost, that's fine, because we'll be doing it together in a second. All right, so let's see how you did. The first step on these is always to separate everything out. Now later on, you'll be doing this part in your head. So just bear that in mind. You won't always be working so hard to get solutions to these problems. It'll be in your head mostly. But we're going to start by writing this all out. So we have a 6. Well, that's actually a positive 6, right? And then we're going to put that in parentheses. That's done. Then we have a negative 4. Now, because in algebra we always add, we're going to add a negative 4 to that. He's done. Then we're going to add the next one, which is a positive 2. And then we're going to add the next one, which is a negative 3. So we'll add the negative 3. That's the first step. Throw everything into parentheses. So it's all organized. All right. Now we can go ahead and use our number line, which I might need to move it because I think we're going to need more room for this. We'll move it down here. And from the number line, we'll arrive at the solution here. So we always start at 0. Just draw a little dotted line up from 0. And now we're going to move 6 units to the right because this is a positive 6. So we go 1, 2, 3, 4, 5, 6, right? Puts us right here. This is our positive 6. Now, from there, we're going to add to this a negative 4. So we'll just draw a little dotted line up to give us room. Negative 4 means we're moving to the left, right? Negative direction, to the left. So we move 1 unit, 2 units, 3 units, 4 units. Puts us right here, which is in line with this negative 2, right? Just so we're clear. All right, so that's the negative 4. Then we have a positive 2. So we start where we left off here. We go up a little bit. Now positive 2 means we're going to the right 2 units. So we move to the right 1 unit and 2 units. Puts us somewhere right around here. We should be pretty much in line with that 4. All right, so we're at 2 units. Positive 2 units that direction. And then finally, we have this -3. So we need to go up just a little bit. And now we're going to move 3 units to the left, right? Because it's negative. So 1, 2, 3 puts us right here. Should be in line with the 1. So this is our -3. And so then we're finished. Our solution is where we ended. We ended on the 1. So the 1 is the solution. So 6 minus 4 is 2. 2 plus 2 is 4. 4 minus 3 is 1. I just kind of double checked it, and that works. Okay? And you might say, gosh, that was really complicated to get to 1. I could do this very easily in my head. And that is very true. These ones are very simple, and you should be able to do these in your head. However, the idea here is to get you used to looking at these problems and seeing them in a different sense. You're seeing them as a 6 plus a -4, and then that answer plus a +2, and then that answer plus a -3. That's the goal here, and we'll be doing more of this in the next lesson. All right? Okay, let's try one more here. So go ahead and pause the video, try this one on your own, and then we'll do it together. All right, so let's see how you did. So once again, the first step is to rewrite this, separating everything out. So we have a -3 plus a -4 plus a +3 plus a +6. All right, and then we start at our 0, the origin, and we move to the left 3 units. 1, 2, whoops, I can draw this. 1, 2, and 3. Put this right there. That's -3. And then we will move to the left again, right? -4. So we go up from this, and now we're going to move 4 more units. 1, 2, 3, and 4 puts us right here, -4. All right, then we move +3. So we go up from here, and we go 1, 2, and 3. And I'm just kind of keeping track with my eyes here down below. You don't need to write this dotted line, but it just kind of helps to see where we're at. So we're at the -4. All right, so this was the +3. All right, this one. Then we have the +6. So the +6, we're going to move to the right 6 units. So we go 1, 2, 3, 4, 5, and 6. Right around there. That's our +6. And that puts us in line with the 2. So the solution is a 2. Excellent. So hopefully that makes sense to you. They will ask you to do some of these on your seat work and, humor them. Go ahead and do it the way that I just did it with the number line. But just have in the back of your mind that you won't be doing this very long. We will be progressing, to the point where we're doing all of this in our head and we don't need the number line and everything else. All right? Very good. So I think we will stop here for today. Good luck with your seat work, and we will continue this concept tomorrow.